I too love the fact that the scales of these different talks have been at different levels, partly because it absolves me of the responsibility of speaking at the most visionary scale, the global scale, even regional scale. I'm going to zoom in on what I know best. It gives me the ability to do that about Alewife, which is two aspects of water quality on Alewife Brook and Little River, as you'll see. But I wanted to start with this slide, sorry, if I can get it to go. This is a digression, but this is video taken on a couple of weeks ago, May 25th. It's my birthday. So my conceit is that the universe was celebrating my birthday by having an especially fast moment of migration of river herring this is up the Mystic River, fish that have migrate annually from the ocean into the Mystic River and its tributaries. And this is a video camera we have at Upper Mystic Lake, where there's a fish ladder installed that allows these fish to get to habitat now for the first time in freshwater habitat they've been excluded from for 100 years. There's a great restoration story here. I'll plug our website for a fish counting program online. That's www.mysticherring.org. And I put up this slide just because it's an amazing moment of fish flying by. As many people in the room may know, there are two species of river herring, migratory river herring. The big scale, by the way, this is now the biggest river herring migration in the state. Over 600,000 fish last year. We're probably over 750,000 fish this year. And river herring are a good sized fish, let's say a foot. That's more than 100 miles of fish end to end. Two species, blueback herring and alewife. And so that is the animal that Alewife Brook and Alewife Reservation are named after. And it's a reminder that these systems are living systems that were connected to the ocean, that these amazing migrants get past the Amelia Earhart Dam in Somerville and find their way up to the Mystic Lake. And they're now getting to Horn Pond in Woburn for the first time in a very long time. So anyway, great story, digression, but a nice frame for the water quality that I'm going to talk about. I'm going to talk about two aspects. One is bacteria, and one is dissolved oxygen. First, bacteria. Today, coincidentally, was the day Ellen sent out a notice about this, that EPA, we with the EPA, announced our water quality report card for the watershed, including grades for for several streams and tributaries. The good news is that the Mystic River, like it has in the past few years, received an A- water quality grade. This is bacteria. Let me pause for a second. How does bacteria get in the water? If you told me that I'm a career changer, so I've come to this domain in sort of late life very happily. If you told me 10 years ago that on a routine basis, raw sewage finds its way to daily, weekly basis into urban rivers, I would have said, no, that's London in 1600. It turns out every American urban river gets sewage inputs on a regular basis. A variety of mechanisms, wet weather makes it worse. So the bacteria we're testing almost exclusively, this is a signal of wastewater contamination of surface water. So the good news is Mystic River is an A-, much like the Charles River, which has famously cleaned up its act over the past 30 years. Alewife Brook and Little River receive a D+. Unfortunately, this is a mapped version of the same, just released today by EPA for 2017 water quality report card. And it's the same data in visual form. The short story here is, if you want to know why there is bad water quality in Alewife Brook and Little River, it's partly the effect of bad water quality upstream in Belmont and Winnsbrook and Wellington Brook, and partly the continued presence of combined sewer overflows, which we can talk about, but they're engineered in very heavy rain events, literally to overflow raw sewage mixed with stormwater into streams so that that doesn't come into your home. So that's bacteria. That's a synopsis of a situation that is long-standing and slow to change. But many efforts are being made to address some of these questions. The second glimpse into water quality I wanted to give is dissolved oxygen. And I think about it in this shorthand way. Things that live in the water have to breathe oxygen as much as we do. Critical for animals and plants. Aquatic organisms get oxygen from dissolved oxygen in the water. It's an indicator of ecosystem health, and the state water quality standard is 5 milligrams per liter. So sort of keep that in mind as we go through these slides. And if you think about how dissolved oxygen works in water, this is a super simplified schematic, and apologies to hydrologists and ecologists in the room, but kind of two main mechanisms for introducing oxygen into water is the interaction with the atmosphere, sort of mixing from the atmosphere, and photosynthesis by plants and algae in the water. And then those are mechanisms for introducing water into the oxygen into the water. What pulls it out are processes that consume dissolved oxygen, so that's plant and animal respiration. Just as we use oxygen to respire for cell metabolism, and decay of organic material, which is a version of the same thing. If there's a lot of dissolved oxygen in the water, you'll get healthy fish, healthy alewife swimming. That is, I think, actually a picture from Alewife Reservation in the winter after, and this is not a sign of a pollution event, but fish trapped in a very shallow pool that iced over. And so now if you imagine a very shallow, crowded pool iced over, the ability of oxygen to get from the air stops temporarily. And all those animals are consuming the oxygen and essentially suffocated in this one small event. That's there for illustration. I'm not raising that as an important issue all in itself facing Alewife Brook. But anyway, so that's the brief view of that. This is data that we collect and have collected about dissolved oxygen. Oxygen is less soluble in warm water than it is in cold water, so the top graph shows the cycle over a year. So in January, you have high levels of dissolved oxygen. It goes down in the summer and up in the winter again. And I really like the graph below. We put out a probe that measures dissolved oxygen in the Mystic River in June. That's when I started, now 4 years ago. And you can see a diurnal daily cycle in dissolved oxygen. So and if you notice the timestamps here, at early in the morning at 6 a.m., start there, dissolved oxygen is at its lowest. And as the sun comes up and photosynthesis kicks in, dissolved oxygen levels go up until the sun goes down, and then the processes that consume oxygen pull oxygen out of the water, and that measurement goes down and comes back up again. So this graph is really a graph of the river as a living system. We're really watching biology change the concentration of dissolved oxygen in the river. I really like that graph. One kind of very notable fact about Alewife Brook and Little River is that it has very low dissolved oxygen in the summer, kind of strikingly low among streams around here. And one of the best graphics we have to depict this is a trip that one of our volunteers and architects of our water quality monitoring program named Roger Freimeyer, who's some people here may know, longtime activist on the Charles and on the Mystic River, took our probe that measures dissolved oxygen on a kayak from Upper Mystic Lake or Lower Mystic Lake at the top, paddled down the Mystic River, took a right on Alewife Brook, came down through that red area up to a little pond, and then turned around and went back. And you can see as he turns out of the Mystic River, so these red values go as low as, so at the darkest red, the value was 0.5 milligrams per liter. Remember, the healthy stream has to be 5 milligrams per liter, so 1/10 of that amount. That's not a level at which fish can thrive. But it's and then he turned around and went back and got just to verify the data. It all went down again and came up again as he came out on the river. We think that the cause of this is sediment oxygen demand. If you remember those CSOs I mentioned before, those combined sewer overflows, we think that there's just enough newly introduced and legacy organic material from sanitary sewers in the bottom of Alewife Brook that when the water heats up in the summer causes oxygen to be, that decay of that material causes oxygen to be drawn out of the water. Very striking finding, but that's the end on water quality, and thank you. Thank you.